Welcome to the first learning outcome, where we get your research project off the ground by agreeing a theme and a working title. It sounds simple, but the choices you make here really do shape everything that follows. So, what exactly is a research project proposal? Think of the project as a planned piece of investigation into a question you set yourself, and the proposal as the short document you agree before you begin, saying what you'll study, why, and how. In computing, that might mean measuring, comparing, building, or evaluating something, and then drawing conclusions from the evidence. For instance, you might set out to compare how quickly two web browsers open the same set of heavy pages. Getting this first stage right matters because a weak title almost always leads to a weak project. Here's a point that surprises a lot of learners. You don't just pick a title, you negotiate it with your tutor. That conversation checks the topic is the right size, that it can actually be researched in the weeks you have, and that there are enough sources to draw on. Say a learner turns up wanting to compare every programming language ever made. A tutor would gently steer them towards something like comparing error messages in two languages for beginners. What you walk away with is an agreed working title you can genuinely deliver. Let me show you how to shrink a big computing subject down to something workable. You start with a broad area, say cybersecurity, then pick a topic inside it, like password habits rather than all of security. From there, you choose a specific angle, perhaps how long people's passwords actually are. And finally, you land on a measurable question, such as what proportion of users reuse the same password across sites. Each step strips away a bit more vagueness. The whole aim of narrowing is to move from a broad subject to a single, answerable question. Every step you take removes ambiguity and makes the project easier to manage, research, and finish on time. A good test is whether you can state your question in one clear sentence. If you can't yet, keep narrowing. For example, going from data storage to storage speed, to whether a solid-state drive noticeably speeds up an old laptop. It helps to separate three words that get muddled: the subject area, the theme, and the working title. The subject area is the broad discipline, like networking or databases. The theme is the angle within it that interests you, such as performance, security, or usability. And the working title is a short, precise sentence that names your study and signals exactly what you'll investigate. For example, an app that surveys how students use their phones during lectures. Let's watch that narrowing happen for real. Imagine a learner who's fascinated by artificial intelligence, which on its own is far too big for a short project. They settle on the theme of how useful AI tools are for students, then focus in on using a chatbot such as ChatGPT to help with revision. That gives them a working title along the lines of an evaluation of ChatGPT as a revision aid for A-level computer science students. Suddenly, it's specific, researchable, and achievable. When you go to your tutor, don't bring a single title, bring two or three. That way you can discuss feasibility together, the time you have, access to data, the software and equipment, and, honestly, your own skills. Agree the scope in writing so nobody is surprised later, and be ready to adjust, because negotiation usually sharpens a title rather than leaving it untouched. Whatever you settle on, write it down, because that agreed title becomes the anchor for the whole proposal. It's worth seeing weak and strong titles side by side. Something like everything about databases is far too broad, with no real question, whereas a comparison of query speed in MySQL and Postgres for a small dataset gives you something to measure. Are computers good is vague and unanswerable, but how does adding a solid-state drive affect boot time on an older laptop can actually be tested. And AI is the future is just an opinion, while an evaluation of an AI code completion tool for beginner programmers is a genuine study. Now we get to the machinery that turns a title into something you can actually answer. 4 words do the heavy lifting here. The aim is your single overall goal, such as comparing solid state and hard disk performance. An objective is a specific step towards it, like measuring boot time on identical hardware. The research question is the precise thing your evidence will settle, and a hypothesis is a testable prediction, for example that a solid-state drive cuts boot time by more than 50%. These pieces stack up in a neat order. Your theme gives you the working title. The title sharpens into one clear aim, and that aim breaks down into 2 or 3 objectives. Together, those lead to the research question or hypothesis you'll actually test. Picture a study on app usage. The aim is to understand daily screen time. An objective is to log hours for 2 weeks. And the question becomes, which app category eats the most time? Each layer gets a little more precise. When you write objectives, aim to make them SMART. That's specific, measurable, achievable, relevant, and time-bound. Specific means naming exactly what you'll measure. Boot time in seconds rather than a fuzzy word like speed. Measurable means deciding your metric and your tool before you start. And achievable means checking the hardware, software, and data are genuinely within reach. 2 or 3 sharp objectives will always serve you better than a long, woolly list. It's worth being clear on when to use a research question and when to use a hypothesis. A research question asks something open, like how storage type affects application load time, and it suits exploratory or descriptive work where you don't yet expect a particular result. A hypothesis instead states a prediction you can support or reject with data, such as solid-state drives loading applications faster than hard drives, and it fits experiments and number-based comparisons. The hypothesis usually comes paired with a null version that says there's no difference at all. Let's pull all of that together with a worked example. A learner wants to know whether upgrading to a solid-state drive is worth it on a 2015 laptop. Their working title asks whether replacing the hard drive with a solid-state drive improves everyday performance, and the aim is to measure the effect of storage type on common tasks. The objectives are to time the boot, an application launch, and a large file copy on the same machine with each drive. That leads to a clear question about how much faster the solid-state drive is, and a hypothesis that it'll cut boot time by more than 50%. So what actually makes a research question a good one? It should be focused, asking one thing rather than 5, and researchable, meaning you can gather real evidence in the time you've got. It needs to be measurable or observable, resting on data rather than opinion, and relevant, both to the subject and to you. A handy checklist is FINER, which asks whether your question is feasible, interesting, novel, ethical, and relevant. All useful things to run a survey idea through before you commit. Before you rush into gathering data, you need to know what's already out there, and that's the background. It's simply what's already known about your topic before you add your own work. It sets your project in context, showing what's been studied, what's agreed, and what's still uncertain, and it reassures your tutor that your question hasn't already been answered 100 times. For the solid-state drive project, the background would cover how the 2 types of drive store data and why their speeds differ. So what does that background research actually cover? You're looking at prior studies and what they found, the key theories and technical terms, and the current state of the technology. You also want the gaps or open problems your project could tackle and a sense of why the topic matters right now. Imagine a study on password habits. The background would pull in existing surveys, the theory behind strong passwords, and the gap that maybe nobody's looked at your particular group of users. All of that reading feeds into every other part of the proposal. A preliminary literature search is where you start filling that in. Begin with reliable places, library databases, IERE Explore, the ACM Digital Library, and good textbooks. Use precise keywords, something like solid state versus hard drive benchmark boot time, and refine them as you learn the proper terms. Keep a note of every source and its key point so you can reference it later, and read a few solid overviews first to map the area. Pay attention to how others measured similar things because their methods can guide yours. Here's what a background section might look like in practice for that drive project. Before any testing, the learner writes a short piece from reliable sources, explaining that solid-state drives use flash memory with no moving parts, while hard drives spin magnetic platters under a read-write head. Vendor documentation and independent reviews report much faster random access for solid-state drives, and benchmarks from tech publications show big gains in boot and load times. The gap they spot is that most tests use brand new machines, so the effect on an older laptop is genuinely worth measuring. As we close the outcome, notice how three things have to agree with each other: the title, the question, and the background. The title names the study, the question makes it precise, and the background shows it's worth doing in the first place. If any one of those doesn't fit the other two, that's your signal to go back and renegotiate before you plan the actual work. Once they line up, you're ready to move on to planning how to carry the project out. Let's gather up what this outcome covered. A research project starts with a negotiated theme and an agreed precise working title, and you narrow a broad computing subject step by step until you reach one answerable question. From there, you turn the title into a clear aim, 2 or 3 smart objectives, and either a research question or a hypothesis, remembering that a hypothesis suits experiments while an open question suits exploratory work. And underpinning all of it, background reading sets your project in context, justifies the question, and guides your method. That's a solid foundation laid for planning your research. If you'd like to go deeper, the further reading gathers some genuinely useful guides: Dawson on projects in computing, Oates on researching information systems, and Bell and Waters on doing your research project, all of which walk you through choosing and shaping a topic. There are also professional resources from the BCS and structured reviews in the ACM surveys that are great for background reading. Do dip into a couple before you start writing, and lean on the ebooks and journals on the Moodle for this unit. In the next outcome, we turn all this planning into a workable schedule and method.